Hello and welcome to my data science project, in which I look at the impact of the weather in the UK on retail sales volume since 1988. So the reason why I selected this topic is because it's of importance to retailing companies, for example, to make decisions about their inventory and their stock, for instance, based on how weather will affect consumer spending measured by retail sales volume. So for this, I took data from two sources and combined it from the Met Office for the weather and the Office of National Statistics for the retail sales. And the first task I had to accomplish was to select which spreadsheets from the ONS to use to measure retail sales volume. So the reason I chose volume over value is because volume is more used for companies who want to make decisions about inventory or stock based on consumer demand. And the next decision I had to make was whether to use figures for sales volume, which was seasonally adjusted or non-seasonally adjusted. We chose the seasonally adjusted spreadsheets because that isolates the effect of the weather more from factors such as holidays like Christmas or bank holidays, where people are going to be buying more products anyway, which makes it difficult to isolate the effect of the weather. So the spreadsheets I chose were KPSA1, which looks at the percentage change on a year earlier in retail sales volume, and the KPSA3. The reason why I didn't just use small figures as seen here without looking at percentage change was because these are measured as an index for base year 2019, and that makes it more difficult to compare changes over time and makes it more difficult to interpret the results of the linear regression, which is why I chose percentage change. Then for the weather data, this is the format for each variable. So here we have mean temperature. We also have the same format for rainfall or hours of sunshine. As you can see, the first task is going to be to format this weather data, which has the month up here for each month and the year down here, which is clearly of a different format than the retail sales, where the months and the year are as one column here. So that is going to be a major task. Then for the data cleaning task, there were two main things to do. The first was that we had to deal with the missing values for 1988 using various interpolation techniques, which will be explored later. Secondly, we had to put the retail sales data and the weather data in the same format. So here the sales data has the year and the month as the index, whereas unfortunately the weather data had a different format with the months here and the years. So what I did to put them in the same format so the data frames could be combined was use the pandas melt function, which gets the columns here and puts them down into row names instead of column names. And after doing that, it converts this wide format to long format, which is what the KPSA figures are stored as. And after doing that, the purpose of that was to combine the weather data frames with the KPSA data frames to allow them to be in a data frame format like this. You can see each month and year side by side, and that enables easier feature matrix extraction, target array extraction, and makes it easier to compare the values. So in order to handle the missing values for 1988 and sales volume figures, I used visualization to compare different pandas interpolation techniques to see which interpolation technique for missing values gave the most realistic looking curve or line graph. So as we can see here, linear interpolation gives this unnatural looking flat line here for 1988, whereas using time interpolation gives a more natural progression of values. So this is the one that was selected to fill the missing values. And now we progress to the statistical analysis, where pandas describe was used to generate the mean and the percentiles. So for the statistical analysis, the most important thing that immediately stands out is that here for the percentiles, the value for the highest percentile at 75% of the data, the KPSA1, is 3.7, but the maximum value in the dataset is 36, and this is a really large gap. So this shows that this dataset probably has a lot of outliers that we have to visualize and deal with here. And this could be seen using these histogram visualizations. So this shows that the data is very imbalanced and heavy-tailed for KPSA1 and KPSA3, as it has a high kurtosis, which means that there are probably many extreme values and outliers in this data to deal with. And this is also shown here when we looked at interpolation, because this fluctuation here shows something that looks like it would be anomalous. So the main task here, which these visualizations really helped with, was to use technique calculate using interquartile range to get rid of these outliers and to identify them. So the way that this was done was by calculating the interquartile range times 1.5 from each side of the values, then removing or using interpolation to remove the outliers. So this was the whole section here where the thresholds, which makes the value be an outlier if it's above or below that, were calculated for each variable, and then the values that were outside of those thresholds were removed from these outliers. So the result of that was that now these sales variables are much more normally distributed, and the kurtosis is only 0.13 or 0.7 compared to the large values of 25 or 30 something that we had before. This more normal distribution gives many advantages for this data and linear regression, as it improves the reliability of the model. So this pair plot lets us see which features were correlated with each other, and as we can see, min or max temperature have a strong correlation, which lets us extract the features which seemed redundant in preparation for training the model. And then, before training the linear regression model, another important step was because we had the same 5 different features. This was difficult to visualize using 2D or 3D graphs. So a technique we use here is PCA, which reduced these 5 features to just T features, which made it easier to visualize the different features for each month. And as we can see here, the KPSA 1 shows that there's not really much distinction between each month, whereas the KPSA 3, there's more of difference and clear clusters of months depending on the variables. So this led to the decision of only using KPSA 3, which is just percentage change on the previous month, for the linear regression task. And then for the purposes of reliability, there's some cross-validation with fivefold, the time series data, which takes a greater proportion for training every time. And then finally, after running the linear regression model, 3D plots were used as there were 2 reduced features matrix variables and then the target array to visualize the plane, which was supposed to be the best fit for predicting whether those weather variables had an impact on sales. And unfortunately, the final results show that the RT score, which measures how well the weather variables predict variation in sales volume, were very, very close to 0 and very low, which unfortunately shows that these variables, at least from the Met Office, this shows that the weather did not really have an impact on the monthly change in retail sales, which is an unfortunate result, but also sort of leads to questions for further exploration. So, for example, wind data was difficult to find, so it wasn't factored into the features, and that could show that actually including wind could have had a stronger relationship to retail sales.